This is Mark Anderson for Kellogg Community College, and today I'm going to look at the second part of the Unit 1 review test for statistics. And in this video we're going to cover half of Chapter 3, which is going to deal with just the parts that deal with averages and standard deviations and z-scores. So roughly page 3 of your preparation for the test. Alright, so we're going to start off with doing a standard deviation by hand. I know that you can get standard deviations on the calculator and also use the standard deviation formula, but for the test, since I want a conceptual understanding of you creating or finding a standard deviation, this is the best way to look at it. Now, the first thing we're going to do is take a look at these gaming system prices. Imagine this is from the early 2000s when we had the original Xbox 360 and the PlayStation 3 and the Nintendo Wii and other handheld devices, and these were their prices. Now, if you did the average of these prices, you would add them up and divide by 7. There are 7 different items here, and I'll indicate that by n is equal to 7. And so just to highlight my columns here, I'm going to write each price into one of these rows here. Okay, so we got 1, 2, 3, 4, 5, 6, 7, and now we are going to find the average in this column. And so we add these up and divide by 7, and if you do so on your calculator, you find out that average is $250. Or equal to the price of the Nintendo Wii back in the early 2000s. Okay, so I'm going to put that here. Okay, now the median. What you would want to do is put all of these in order from lowest to highest, and then find that price that would be in the middle there of these 7 items. So I'm going to reorder them here from low to high and cross them out as I do. So there's 100. There are 2 150s. And this way, if I keep them written above each other, I can see if I skipped one accidentally. There's 200, which will be my median. Then there's going to be 250, 400, and 500. So that is all of my data listed in order from low to high to find my median, and that median is right there in the middle. The mode would be whichever number showed up the most, and in this case 150 showed up twice, so there is a mode. Now what we're about to do is, in this column, we're going to put the difference between X bar and the price of those gaming consoles. And you can see I put absolute value symbols there because I don't actually care about whether it's above or below, because the difference, once you square it, is going to be positive anyway. So the difference here is 0, the difference here is $100, another $100 difference, a $150 difference, $250 difference, and then a $50 difference and a $150 difference there. Now, in the next column, what we're about to do is we're going to square those differences. So I will abbreviate that as the absolute value of the differences squared. And 0 squared is 0. 100 squared is 10,000. And we could copy that. 150 squared is 22,500. And 62,500 here. 2,500 for 50 squared. And then 150 is 22,500. Now what we do with all these differences squared is we add up them and put them into this column here. So this is the sum of the absolute values of the differences squared. And if I do so, 0 plus all these 6 other values will give me a total of 130,000. Now, to find my variance, I'm going to take this and divide it by 6. And what I said before, since we're dealing with less than 30 pieces of data here, we're going to do something that I haven't necessarily talked about degrees of freedom, but we're going to divide by n minus 1 to process this standard deviation under 30. This is kind of a because I said so. So you take your 130k, divide it by 6. So you're always dividing it by n minus 1, since we had 7 pieces of data here, divided by 6, and that gives us 21,666.7. And we'll round to 1 decimal because of our boundary rounding rules. Then to find our standard deviation, because we're 1 step away from that, because the difference between the variance and the standard deviation is just the square root, we're just going to take the square root of this number here. So the square root of the 21,666.7, if you take the square root of that, then you get 147.2, or $147.20. Now let's move that down a little bit, knowing that, and this for the picture we're about to do on the bottom half of this page, we will need to know our mean, and we will also have to know our standard deviation. So let's go and move the screen down, copy down all important information before you move forward in the video. Alright, let's go and take a look at the bottom of this video here. Okay, so we're going to make a picture of that normal curve. And again, our important information was knowing the mean, or the average. So let's make a normal curve like so. Okay, there's our normal curve. And in the middle of our normal curve, we're going to have $250. Okay, that's $250. And we're going to go 2 standard deviations away from the norm. Everything within the first standard deviation is considered normal. So there's our first standard deviation above and below the norm. This is our average, and this is going to be our second standard deviation. And for those of you new to me, this is a cursive letter S. My lowercase s's look like 5s, so I use a cursive letter S when I write stuff down for standard deviation. Well, if I added $147.20, I'd get $397.20. So this is considered 1 standard deviation above the norm, and 1 standard deviation below the norm would be $102.80. This is subtracting my standard deviation of 147.2 from my average. So everything within these two marks here, within 1 standard deviation above and below the norm, is considered normal. So your normal video game system prices were between $120.80 and almost $400. But if we go 2 standard deviations above the norm, which really gets into the extremes of the data, then we have some of the weirdos, or 2 standard deviations away was $544.40. And then if we go 2 standard deviations below the norm, this gets us negative numbers. So that doesn't really apply in this real life context. But you can see that the normal video game systems were within this 34%, or as I've kind of made it easier for us to start to learn about this, 2/3 of the graph roughly is this in this normal range, whereas a 1/6 is in this range, and a 1/6 is within this range, and these are kind of the weirdo prices here, anything below the $100, anything higher than $400. So that's what and how you would do a standard deviation. Now a z-score, you should know what a z-score is by definition, and this is something I'll ask on multiple tests and final exams. The z-score is the number of standard deviations, D-E-V-I-A-T-I-O-N-S, the number of standard deviations you are away from the norm. And the norm is in quotes because when we say norm we mean the average, because standard deviation refers to an average. So this is something you'll have to know word from word, and you have to know the word standard and deviations here. It's the number of standard deviations you are away from the norm. So you want your z-score to be positive first of all, and then you want your z-score to be probably closer to 2 to be considered normal here, or actually above normal if having a higher standard deviation or having an above average score is good. Let's assume that. Let's assume that earning more points on the quiz is good. So let's say you got 30 points out of 42 average. So maybe this is a 100-point quiz and you got 30 points, but the average is 42, and then you're going to divide that by the standard deviation to find your z-score, because the z-score formula is this. The z-score formula is z is equal to your score minus your average divided by the standard deviation. So that is your score minus the average divided by the standard deviation. So let's say you took a tough 100-point quiz, you got 30, but the average is 42. That means that, but with a standard deviation of 7, so it looks like the class is pretty low on this one. Well, that still puts you at a negative 12 points below the average divided by the standard deviation. You got a negative 1.7 for your z-score. So you are almost 2 standard deviations below the norm. That's pretty bad. It's pretty bad if you're trying to be, in the pack. But let's say you took another 100-point quiz and you rallied and you got 61 points and the whole class got a 55, so your score beat the average. And the standard deviation of this test was much wilder. It was much higher, normally 12 points above and 12 points below the 55. Well, that still puts you above the norm, which is 6 over 12, and this gives you a 0.5 for your number of standard deviations above the norm. You're halfway to being 1 standard deviation above the norm. Now, I do want to emphasize once, and actually probably one of many times, that these numbers here, these numbers are not percentages. This is not negative 170%. This is not 50%. This is how many standard deviations you are away from the norm. Where you can use this, and we will be using this in the next chapter, to find percentages. But at this stage of the game, please do not get confused that this is not a percentage. This is how far you are away from the norm. So if you had a normal curve like so, and this is your x, and this is 1 standard deviation above and below the norm, 0.5 would be right here. That's where you would be on this vertical line, showing where you are. And it's still close to the average, but above the average, that's for sure. And if you got negative 1.7, you'd be like way down here at this dot, showing you far away from the norm. So again, do not confuse these numbers with percentages, though we will find percentages with these later to see where you are in the percentile of the class. All right, thank you very much for watching.